So I'll just start with a little background. Probably about a couple of months ago, myself and Greg spoke about different ways how architects could contribute to the architecture community and to, boost the knowledge and understanding of what the architecture is about. And this idea came up to have a review of a generic subject, namely, what is solution architecture? Who is a solution architect? What does it mean to create a good design? What does it mean to create a good architecture or a good solution? So it is quite a broad subject, and I must admit, in the beginning I was a little bit puzzled because I wouldn't want to, write a PhD on this, but at the same time I wanted to have a review based on the experience. So I came up with sort of a presentation that I'm going to present in this session, which gives an overview of what architecture could be about. And it might be quite useful for people as well who are aspiring to become an architect and who are currently perhaps in some engineering roles, like a lead software engineer or others. But I think it would be also useful because the material is not going to be groundbreaking or revolutionary. It's probably something that you are familiar with or already encountered in your roles with Kainos and previously as well. But I wanted to sort of bring it under, put it in, put some sort of a classification to this and to give you some ideas of what it could be, what activities could be done by a good architect. So what I have done is I've broken down the architecture work into 3 different areas, and I gave them very short names. The first one is anything related to technology. The second one, anything related to non-technology or soft skills, something that you would need to possess to be able to be an architect or to be a successful architect in a project where you have to interact with people, work in an environment, also understand that you are just one company in a big marketplace and you will have consultants from different consultancies and you will also have employees around you from the client, and what kind of skills could be important for you to fulfill your role in quite a complex environment, which is often the case. And then finally, the third lens to look at the architecture role would be a business view, because we operate not just as individuals, we are all part of a corporate entity called Kainos, and Kainos is a going concern. It creates revenue, it makes profit, so we should be able to have an awareness of this, but also to contribute to that. So these are 3 different angles. What I would like to do in this presentation, as much as I can, in the probably 45 minutes, to go through these 3 areas and explore them in sort of a lower level of detail, not necessarily a low level of detail, but at least go one level down and see what's underneath that. Those 3 areas and what it means, or what could be the example activities that a solution architect or a technical architect or even a principal architect could perform in his role. So let's look at the technology first. What I used as the foundation for the technology lens is pretty much a life cycle of a typical delivery, where we have the business need or client requirements or just requirements, and there has to be some effort to design a solution. Then that design needs to be implemented. This is a development phase. Then obviously you need to check whether the final product or the delivery in this implementation actually meets the needs identified in the beginning. And then obviously you put this solution into production, and there is a live phase where you have a system or a solution that runs at the client side. So this is, I described a waterfall approach to the delivery, but obviously if we talk about agile, this would be a structure of one iteration, but there will be a number of those iterations during the project, each resulting in a delivery. But an architect would be involved in each of the phases, and underlying each of those stages in the delivery cycle would be three activities, which is the governance, or to put it simple, is how the design decisions are made, and what is the process, and what is the structure behind the delivery, and most importantly, behind the decision-making process. The next one is arguably doesn't belong here, but I still put it under the technology section. It could be described as a non-functional requirement, but I still put it in here because the security is sort of underpinning each phase here, and it's a concern that needs to be addressed during the entire delivery cycle. And then finally, tools. There's quite a lot of different instruments, tools, systems that an architect needs to be aware of, and also to perhaps recommend for the implementation or for the use during the delivery. So there is pretty much 8 building blocks that constitute the technology, and I would say that probably the most interesting one from the architecture point of view is the design phase. It's probably 60% of everything that architect does. However, it obviously is different for each project, but it is something where we get involved quite a lot. But there are security domain is also quite important, but quite often it is done by an SME or a specific domain architect that deals with security. But I would say that 60% of the activities are in the design phase, and that's why it is probably bigger than the rest of them. So what I wanted to do now is to go through each one of those and just to look at what constitutes the typical activities and what the solution architect or technical architect needs to be good at when we look at the specific areas that I mentioned. So when we look at the design, there is, as you know, 2 big areas, which is functional, anything related to what the project does, or what the delivery does, or what the product does, and then non-functional is how it does it. So these are 2 areas which we need to address separately. When we look at the functional design, I've put this sort of technology stack focused bits that usually need to be looked at when you design a solution, which is the underlying infrastructure, which runs the system or the solution, then the data layer, or where you persist the information, application, which is anything related to the actual business logic, and the presentation layer, which could be web-facing or mobile user-facing, which is a user experience. And quite often, when the system quite often the system is not isolated, but it needs to interface with the existing components or perhaps with the newly developed components. So the integration is quite important. And very often this is called domains, and you probably know that there are data architects, there are application architects, maybe UX engineers, maybe infrastructure or network architects, integration architects. So there is all sorts of terminology used, but it is pretty much an area that an architect needs, a set of areas that an architect needs to be aware of when the solution is designed. So that's the functional bit. And then finally, when we talk about design, it's a non-functional, and there is quite a number of non-functional aspects. I mean, I didn't want to list all of them, but I probably selected the ones that are important in every single project. We could add or remove, but just to start the discussion, it is scalability, which is the ability to provide the solution when the usage level or the load on the system or on the solution changes. Availability, which means that we need to constantly provide the service rather than tolerate any faults or interruptions to the service. Performance is how fast the solution, in fact, performance is one of the key areas. For example, how fast is the response time to the user on the web interface, for example. And then another one that I included is zero carbon. It became quite important recently, and I just wanted to mention a couple of points on that as well. There is others as well, so I didn't speak about compliance, I didn't speak about documentation, usability, maintainability. Sometimes security is also classified as a non-functional requirement. Although it is sort of a gray area, security can be non-functional and functional as well. But we'll look at those four. And then when we speak about the soft skills, which is a second lens to look at the architecture activities, again, there's quite a large number of soft skills, but I wanted to mention a few which are quite important. Obviously, an architect works in an environment with a lot of different players, a lot of stakeholder, the client, different consultants, business representatives, sponsor of the project from the funding perspective. It is sometimes quite complex, and it is a skill that is quite important for the architect to efficiently deal with stakeholders that surround you in the project, in your day-to-day work, and be effective in that. Next is communication. Ultimately, an architect is the person who converts business need into technical capabilities within the company, and it is important to be able to articulate what exactly and how exactly you are going to achieve what you aim to achieve in the end of the delivery. Leadership as well, it's probably less important for junior roles, but becomes more important as you advance to a more senior architecture role. It is people management, it is to be able to influence, it is to inspire people, and to also be able to become a thought leader for the group, and also to be respected and to build a reputation. And then one interesting area as well I wanted to touch upon is conflict resolution, because we are many different people with different views on how things can be done. And quite often the views are opposing, and you have to be able to come to some consensus, sometimes reach a compromise, and to find the solution and to move forward, even though different people have different views. So that is soft skills. And then finally, the business angle at the architecture role. There are four areas that are mentioned here. The first one is business development. Obviously, we are part of the big company. we are contributing to the success of the company, and we, in interacting with the client, are able to spot opportunities and to convert them into the change and the growth for the client and for Kainos as well. So that's quite an important angle. Public image is how we are seen from outside, and also how the architecture community is seen from inside, whether we add value internally and whether we are visible externally. And there's a few things that an architect can do to enhance the public visibility. And finally, we have a strategy. It was actually distributed and published until at least 2025. And as an architect, we do have a way to influence the company's movement towards the strategic goals, and we have to contribute to that as well. And I'll mention a few points on that. So essentially, these are the areas. There's probably about 20 of them, and so what I wanted to do is to go through them, not necessarily all of them, but maybe some of them that are important. Greg, I don't know whether it makes sense to make a pause here and to get some questions, or is it better for me just to go on and maybe a quarter to I would stop and then take questions.
Well, we can have a quick pause. Any questions so far? I think you're good to go.
Yeah. So if we look at the technology angle, the beginning of the journey is the business need. And it's a good architect would always be able to understand on the one hand, what is the business goal of the client? And on the other hand, on a smaller scale, what is the technical need and the business need of the particular engagement? And the client would normally already articulate to you. You don't need to discover those. You would probably be able to see the short-term goals and long-term strategy of the client. And it's important to take that strategy into account when you design your solution for a particular engagement. And obviously, it is also quite important to understand the business requirements of a particular engagement. So if we take, for example, an automation of the customer management flow, and the current process is manual, so the goal would be to put the system in place, but ultimately the strategy would be to increase the client base of the client, the customer base of the client. And ultimately, the role of the architect is quite simple. It is to convert business requirements into technology capabilities, and also to not only create the design, to carry out and perform such a conversion, but also take everybody with you in terms of approval, agreement, sign-offs. And in this last point, it's quite important to link business need phase to the governance, because governance is about decision making, and be effective and govern the process is quite often a 50% of success to put a good design in place to meet the business requirements. And like I mentioned, business needs are not static. They develop throughout the project, and in the agile approach, you will have to be flexible enough to go through iterations and adjust and adapt the decisions and designs that were approved and perhaps signed off earlier. So that's also a skill. Generally, on each of those areas, I put a few bullet points, which are sort of a representative sample of the activities that the architect would be involved in that particular area Then in the bottom here, I would have Kainos reference. And if you click on that, you would navigate to a place on Kainos SharePoint where you have some supporting material on this particular area. So when there is a star in front of the Kainos reference, it means that I haven't actually found the information on Kainos intranet. So it doesn't mean it doesn't exist. It's just in the time I had, I wasn't able to find that. And maybe it is missing, maybe it is somewhere, but it is something that we need to look at perhaps later. And quite often, as you work through the project, you would create so-called architectural artifacts. This is sometimes a document, sometimes a diagram, sometimes an Excel spreadsheet, but it is something that would contain useful information that reflects what you have achieved and what you have done as an architect. And in this particular case, a common abbreviation would be BRD, Business Requirement Document, which would normally be compiled and written by somebody outside of architecture, but an architect would be a part of the review and certainly would need to understand what is required. And there shouldn't be any requirements that an architect doesn't understand. The other quite useful document, which quite often already exists when there is a mature architecture function with the client, is the architecture roadmap and the target architecture. And the solution that is being put in place would be just one little step along the roadmap to achieve the target architecture. But it's quite often it is quite useful to understand how that is fitting with the roadmap and how that moves the overall enterprise architecture closer to the target. Then there's some planning involved, usually done by project management, and then a suggested technology path. This is where the architect would be involved to suggest how the technology capability is going to be achieved using either the existing or emergent or new technologies that are available on the market. Okay, so if we go next is the infrastructure. So here is quite important to be aware of, I guess, the current trend is moving away from on-premise to cloud, and cloud infrastructure partners that we use quite actively is AWS and Azure. Google is probably something that we are starting to engage, I saw, but not at any level of maturity at the moment. But we are quite experienced in implementing AWS and Azure, and it's quite important to be aware of the compute networking storage services on each of those services. Quite often it is a decision for an architect to go either serverless or server-based design. So that is one of the typical activities where you design the solution, whether where you need to make the decision and what Kainos could provide on each of those points, not necessarily serverless or server-based, is some guidance and some sort of a, I would say, decision template, which I don't believe exists currently, but it is a separate point of discussion. Ultimately, what I would like, and I think we would like to happen, is this would prompt to some probably improvements in how we organize and how we structure our architecture knowledge base that can be reused in many projects by different architects. Another quite often you would be involved in the migration activities. There's probably no clients that are not, there are no clients that are not thinking to move away from on-premise to cloud. Sometimes there are restrictions and it's not possible. Sometimes it's not feasible from the cost point of view. Sometimes it is the infrastructure is so complex that it's probably delayed until later. But the projects like that are quite important. So that's another infrastructure type of solution design that could be happening. Of course, migration, it's not only about infrastructure. It could be lift and shift, where you don't need to do anything with the solution, but it could be a complete rewrite when you moving a system that currently does a function less efficiently onto the cloud, completely rewriting and using the cloud native technology. So that is one of the examples. Then you would quite often need to look at the networking components, how organizations connect and talk to each other. It's quite important to understand zero trust is quite a common approach that doesn't allow any components that are run internally within the security perimeter of the organization to talk to each other unless there is a reason, as opposed to how it was previously. Anything within um, the security perimeter of the organization is supposed to be secure, and therefore security considerations are less strict. Again, selection of the components from compute, networking, storage on multiple clouds, and then also taking into account the cost-based design, which is sometimes the design is so elaborate that the budget is not sufficient to deliver it. So the architect would need to take into account not only to create a perfect design, but also that this design would fit within the budget allocated to that particular delivery or product. Next layer is data. So this quite often is done by data engineers, but or data architects. And in fact, we have the entire data and AI capability with a lot of subject matter experts on this. But the typical design decisions for a solution architect would be a selection of, for example, NoSQL versus SQL, relational platform, selection of the database platform, knowing CAP theorem, for example, which is the fact that consistency dimension, availability dimension, and partition tolerance dimension cannot be achieved. You should select two of them, and based on what is required, which two are required, you choose your data platform. Second point is the service type on AWS and Azure. There has to be awareness that database service is delivered in quite a few different flavors. And the spectrum is starting from fully managed by the cloud provider to fully managed by the customer. And there are types in between, so it's important to make a decision to implement the right type of data service for the solution. It's important to understand different storage type, redundancy on the cloud platforms. And finally, I wanted to mention as well is the media storage and retrieval. It is especially important because there's quite a large footprint that Kainos has in the medical industry, and it is quite often a lot of video, audio, and generally media storage that needs to be done, such as MRI scans and X-rays and things like this. Again, if we go to this reference, then you will end up on an intranet page for okay, I think it's not clickable in the presentation mode, but it will take you to data and AI intranet for further information. There's quite a lot of resources on this subject. And what I'm listing here is by no way a comprehensive list of activities. It's just some examples of what you could be involved in. Application. So here is probably it is quite a big chunk, and here I just wanted to mention that in terms of designing the conceptual architecture, there are different approaches, different frameworks, and TOGAF is quite popular. However, it happens so that in Kainos, we are more in favor of C4 framework, and it is quite important, I think, to get yourself familiar with that. There is quite extensive set of documentation on that on the web if you search for C4 architecture methodology. It is important to know the best practices, and we have a repository of different types of best practices. It's also, I wouldn't say it's complete, but there is at least some of them. And as an example, when you're designing microservices, there's a few patterns that you could follow and few design approaches that can be used. Different types of documentation are produced as part of the application design. Sometimes they're called HLD, LLD, high-level design, low-level design. Sometimes it's open design proposal or ODP, or it could be some terminology that the client uses. But generally, it is something that it is a document that describes your design, and it usually would contain a number of diagrams. Could be some UML diagrams, could be some diagrams prescribed by C4 approach, but it is a document that is produced by an architect, and usually a solution architect. The first document that would be produced, even at the stage when the client hasn't engaged yet, is some form of high-level design of what the solution is going to look like, what would be the technology stack selection, and so on. UX, I think important bit for an architect is to have awareness of GDS standard, because we have quite a large footprint in the public sector, and GDS standards are quite well documented, and the a well-known approach that is used on a lot of projects. So that is something that every architect should be at least aware of, and also to some level of detail know what it actually means to develop the user interface following GDS standards. Next one is the awareness of the IDE toolset platform for the development. The architect would normally not be involved in coding, but the toolset and the for example, the languages, the programming language or the engine behind the API business services, the type of business services, the interface standards. There is quite a variety of tools, and there has to be awareness of what is available, what is the client preference, and what is the Kainos recommended approach. Again, I'm not mentioning any specific technologies here, but it is something that we need to be aware, and there has to be a list of what we are familiar with and what we are using, and actively promote and recommend as well to the client that would like to use a modern tool set to develop the application. Next is the mobile UX. I mean, this is something that the architect needs to be aware of. The decision between, for example, hybrid and native development for two leading mobile platforms, Android and iOS. A couple of other points I mentioned here is content management platform consideration. Sometimes it is an architectural decision to choose between doing your own development, design and development to meet exactly the requirements of the client, or to use a content management system, do the templates, and let the client business users to actually fill the templates with the content. It is an architectural decision and needs to be taken into account. And then consideration for low-code platform. There's quite a few of them in Azure and other cloud platforms, and standalone as well, where you would pretty much not rely on the developers, but allow the business users to construct the interface. I think one of them was presented a couple of weeks ago by Manoj for GovUK forms, where the standard information collection business flow can be quite easily constructed by the users without any development using the third-party tool. And accessibility design as well is quite an important subject that an architect needs to be aware of. Okay, so on integration, it is the final block in the design section. So we need to be aware of API integration platforms and API gateways. That's quite a common way to connect systems together and to exchange information between various components of the IT landscape. Okay, so on integration, it's like one interesting decision on integration is push-pull decision, which is who initiates the data exchange. Where we send information, whether we send information or we poll for the information to be present at a particular location. It could be a synchronous exchange, could be asynchronous exchange, but it's an interesting design decision, and quite often it is an architect that would need to make such a decision. Touchpoint design as well. What is the exchange format? What is the unit of service that sends the information, whether you send the whole lot as one batch or whether you send it bit by bit. So this type of decisions would normally be at the technology level and done by the solution architect. And quite often you have externally controlled versus internally controlled components. What I mean by this is sometimes you interface with the system and you have absolutely no control over what is happening there. So this is quite an important consideration, to consider the recipient or the sender as a black box and to be able to deal with that. And there are techniques how to design solution based on that. The next part is implementation. This is when the design is ready and the solution is being developed or delivered. And at this place, you would need to look at different ways of delivery. So again, there's a big difference between the architecture involvement in the process where the project is run using one of the flavors of agile delivery, and versus SDLC, where you have BDUF approach, big design upfront. There are use cases for both of them. Quite often people ask, when would you need SDLC? Everything is done agile now. But there are projects where you have to do a big bang approach, like when you launch a rocket, the rocket either goes into space or blows up, and there's no iterations in there. You just have to prepare everything for that. It's not strictly speaking an IT project, but there are IT projects like that as well. So SDLC still has its place in the development space. But you have to be able to do a flexible design, and you have to adjust and collaborate during each iteration and adjust your previous designs, or sometimes even abandon the previous designs and create new designs as the project goes ahead. And you have to always consider option B, C for the delivery when the option A, which was initially selected, doesn't work. And obviously, at this stage, when the development, when the design is ready and the developers are following the design to create the delivery components, the solution architect role is probably smaller, but still you need to be involved in the delivery planning to adjust if the delivery is too aggressive or too optimistic. And then you have to be aware of all the risks, assumptions, issues, dependencies, and provide recommendations to the project. However, at this phase, probably an architecture role is less visible. It's more from the oversight point of view. Okay, so the next one would be quality assurance. Here I wanted to mention a couple of things that quite often come up in the project. Quality assurance is the phase where you actually now know that you have a product that can meet the business need identified here and should follow the design that you have created for the project. And this is where sometimes you discover that it is not actually following the design, and you have to do some recommendation in this particular situation. And quite often in the TDAs that I was involved in, the decision was accompanied by the waiver, which is would normally be a discussion during the TDA, a technical design authority, where the design decision is reversed or changed, and there is a record that the design is not implemented as per the original version, but changed and due to the particular reasons, because sometimes it's cost consideration, quite often is the cost consideration, and sometimes it is the technology that promises a particular feature doesn't have that feature, and then you have to change it. And quite often when it's quite a complex project, such changes are decided without architecture involvement by the development team, and you only discover that this has actually happened during the QA phase. So that is something you have to be able to deal with as well during the solution design and during the QA phase. And then finally, a couple of points on the internal architecture quality assurance. We have a way to do a peer review on the architecture work that is done. Sometimes you work in the isolation, you produce your design, and you would like to check with people who had experience in this particular domain previously, and that's quite important to do such peer review and to adjust your design based on the experience of others as well. So that's also quite important. And again, there's a kind of reference here to our QA and testing practice, which is quite extensive. There's a lot of material on this. So this is quite well documented. I would say it is so much information in there that it's difficult to know what is where, but nevertheless, the information is there. And then on the architecture involvement during the release into production or live phase, I wanted to mention a few points. So this is where solution architecture borders with the enterprise architecture. Enterprise architecture is looking at the design of the entire enterprise, where the system that you have just implemented is just a small cog that does one function in a mechanism that delivers the entire strategy of the organization. And it is important to see how your delivery would impact the entire landscape and to make decisions such as like demise design, because the new system or the enhanced system might mean that you need to change 3 different other systems, how they work, and sometimes you need to demise them. And quite often when the program delivers a number of solutions, you end up with a number of systems that need to be demised in an orderly fashion. And that is the decision to review the entire landscape, see what works, what doesn't work, what can be kept, what doesn't need to be kept and needs to be disconnected, and then pretty much design for the demise of those unnecessary components. So that is already part of the enterprise architecture function. And then another important point here is each solution design, each solution delivery is an investment for the company, and you need to understand whether that investment achieved that result. At least you need to be aware. It's more for the people in finance to understand whether the investment for that project works out or not, but you also need to be aware that this is ultimately an activity funded by the company in hope to achieve some return, and you have to be aware of that as well. Okay, so now a few points about governance. Governance essentially is about decision making and documenting what decisions are made. And the decisions, when we speak about the architecture, are the design decisions, and they have to follow a particular order and a particular process. Quite often it is driven by the policies, standards, guidelines established not by you, but by the client. So you have to be aware of that, and you have to be able to blend into the process and to contribute to the decision-making process. You also need, because each decision is supposed to contribute to the target architecture, so the awareness of that and the roadmap to achieve is quite important as well. And TDAs are quite interesting meetings. This is sometimes quite heated discussions where opposing views are discussed and the decisions are made by the majority or by the person with most that has most power. So you have to be able to deal with that, with those situations. And it is more about the soft skills rather than the, so basically governance is more about the soft skills rather than the technology skills. Security is a huge subject. I don't want to go into any of the details. Just want to say that a couple of points here. There are two dimensions to security. The first one is to assess the current state or the current posture, and then the second dimension is to suggest ways to improve the posture for the future in the current engagement. And in any engagement, the security is quite an important aspect. And probably the key point here is about authentication and authorization, or who can access and what those people that can access the solution can do in the solution. And it is important to understand different flavors of Azure security design, because Azure is Microsoft based and probably 90% of the organization, if not 99, have Microsoft legacy, not legacy, but Microsoft operating system 10 years ago, and it logically evolved into Azure Active Directory. And each architect would need to be aware how to integrate authentication and authorization with Azure offering and how to enable external access using B2C or B2B offerings. Just a couple of months ago, Microsoft released the new family of security products under the umbrella called Entera. So this B2B and B2C is now in this family. So the familiarity with this new functionality would be quite important. There's quite a huge number of different frameworks to be aware of, like ISO 27001 or WASP, probably everyone knows, but there's like NIST in the United States. There are SOC audits of different types, PCI DSS for payments. So all this is extensive, large, multi-page documents that describe various standards, which a solution architect needs to be aware of, not necessarily remember all of that content, but at least be able to comfortably discuss security aspects of the delivery that refer to those frameworks. And DevSecOps is quite an important aspect, is embedding security controls and security checks throughout the project lifecycle, starting from the business analysis and finishing with the live delivery, where security concerns are addressed on the spot without waiting until the solution is designed and delivered, but at every stage of the project delivery. And again, security is quite an extensive knowledge base on our, there is a cybersecurity unit, and we have a lot of material which this link will take you to. Right, I'm going to skip, well, actually tools is quite important. So underlying all of that is the selection of tools. And there's probably hundreds of different solutions. There are certain things that are quite common in most of the organization. Others would be a preference, and a solution architect would need to be select. So when we talk about version control, probably Git is the most useful, and it has certain language, and you need to understand branching, merging, and how the code or change is promoted into different environments and merged together for the final release. But Git is not the only one. There's a number of other tools, and you have to be aware of the version control tooling. Continuous integration, probably Jenkins is the most interesting tool that is used quite extensively, but there are others as well. Continuous deployment, there's probably three most visible tools are Ansible, Puppet, Chef. There's also others. Containerization and orchestration. Again, it's quite an important aspect to understand Kubernetes, how Docker works. Infrastructure as code is quite important. It's cloud formations, and Terraform is a platform that is used by quite a lot of clients. Collaboration, communication, Teams, Slack, Alsatian, Confluence, Jira. So that is also quite important. Test automation. Here we have quite a lot of tools that, but we do need to be aware at least of some and to be able to recommend some. Code quality like SonarQube is also quite important. Will Hamill made a presentation on generative AI, which I also put into the tools section. This is something that helps you write code and helps you make less bugs and less mistakes. And from the architecture point of view, it is not really about what it does, but about the selection of a particular platform that does it better than the others. And maybe it is different platforms for different languages or different tools. Okay, I think, Greg, there's 4 minutes left, and I think I'm in the middle of this. I think I'll pause for the questions and maybe cover the rest at some other session.
Fantastic. That's a really, really great talk, Mikhail. Thank you ever so much. Andrew, you still on the call? You had a really good question. Don't think he is actually. Let me just find his question in the chat. Are there easily recognizable hallmarks of flexible architectures or ways to identify rigid ones? Would it be possible to make a catalog, or is it very context dependent?
It's quite a broad question, and I don't think there's a recipe for implementing a flexible architecture or a rigid approach. In different projects, it's a different approach. I think what we need here is some sort of guidance. What are the criteria for one approach, and what are the criteria for the others? I don't think they exist at the moment, and at the moment, it's at the discretion of a particular architect that makes the decision. But to have some guidance from us as a community, it would be quite useful. But I wouldn't say yes or no, or in favor of that or not in favor of the others.